Hello and welcome to this episode of T-Tech. This is part 1 of 3 in our 3-part series to set up a network firewall with Linux. So the first part here is I want to introduce the concepts to you. And then in the next part, we're going to actually configure all of this on our new Linux machine. And in the third part, I'm going to walk you through checking to make sure everything is working that we configured. And during that time, I'll also explain why it's working the way it is. So, real quick, anytime we're creating any type of firewall, a custom firewall, what we're trying to do is take an internet connection from our ISP, so our internet service provider. It doesn't matter if it's cable, if it's satellite, if it's fiber, or if it's DSL. Any of the major ones will work just fine. The reason being is a lot of the modems now have an Ethernet port as the customer side of it to connect into your equipment. So we're going to have 2 Ethernet NICs that are going to plug in to our machine. So once we do that, though, and set this up, we're going to essentially have a WAN side and we're going to have a LAN side of our firewall. And the wide area network side is everything we want to keep out, essentially. Yes, we have to use it to get out to things and resources on the internet, but we don't want it talking to us unless we started a conversation, you see? So, it's kind of similar to someone knocks on your door and you check first and then you open the door. You wouldn't want them to just be able to open the door without you telling them they can, see? So the LAN side, local area network, on the other hand, is everything we have that is trusted. Now you can control what goes from the LAN to the WAN even further, but normally we allow everything from the LAN to the WAN, but nothing from the WAN to the LAN, unless it has something called state for that. But that is our setup. This is one Ethernet NIC here. This is what this line represents. This is our second Ethernet NIC. This goes into an Ethernet switch. It does not have to be what's called a managed switch. It can just be a normal switch. And then you have these PCs connected. And off of this switch, you would also have potentially a wireless access point. But with that, moving forward, if any of our PCs on the LAN want to talk, PC2, for instance, he's going to use something called ARP. That's Address Resolution Protocol, because Ethernet has to have a MAC address in order to communicate. So essentially, he would just ask for our firewall's machines. The firewall has a MAC address on its NIC. PC2 is going to ask for it, and then it's going to receive a reply from our firewall. But once it gets that, it can send any type of traffic it wants. It has its MAC address now. So, as we see, we send the packet, step 1. Step 2, the switch gets the packet. Remember, switches use the destination MAC address to decide where to switch a frame, so what port it goes out of, and it learns the source MAC address of PC2, so we don't have to repeat the ARP process after the first time. And then, though, the switch is going to forward it up to the Linux machine. Now, the next parts all take place inside our Linux firewall. So, we have something called NAT, and NAT is Network Address Translation. Now, this is only used in IPv4, not in IPv6. There's some use of it, but that is beyond the scope of what we're talking about. Here, though, we are now zooming in on the IP addresses actually assigned to our firewall. The LAN side will have 192.168.1.1, whereas the WAN side will have 192.168.0.25. And these are private because I have a network in place already that this is connected to. So this concept that we're talking about will work the same even once you plug into your ISP equipment. It works the same in a lab as it does in production. This is technically a private address. Yes, it is. but the concept of switching it out will work the same. All right? So, when that packet from PC2 comes in, its source address is 192.168.1.3. It's layer 3 address. Before it is routed out of our Linux firewall, it should be the WAN interface IP address that our Linux firewall has. Otherwise, the ISP will not route it. And as well, you could only have the first PC to send traffic would be the only one that can use your internet connection. All right? So we want to just take that source address at layer 3 in the IP header, and we want to change that to 192.168.0.25. And then after we change that address, that makes an entry, a translation entry. But once this is done, then we can route the packet. So if your computer talks to google.com, once it has the IP of google.com through DNS, it gets its address, it puts that in an IP header as a destination address. And what Linux does is its network stack looks at that destination address, and it has its routing table like as a book, and it compares that destination address value with entries in its routing table. So that allows it to select what's called the outgoing interface or egress interface to route that packet over. In this case, it routes it out of the WAN in this case. So it would route it out of the WAN. All right? And that doesn't create state. That just will route. That's why we have to have a firewall on top of the routing. Because this machine is going to do routing and it's going to do firewalling as well. It's going to do both things, but they are separate functions, even though they're combined in one machine. So, what happens when traffic comes back through? Well, the thing is actually going to happen in reverse. So the first thing that has to happen is it has to come back into the machine. And then that state we discussed, it's going to check that as another of its tables called contract. And that's the state tracking table in Linux. Once it checks that, the traffic from Google, let's say, is going to come back destined at layer 3. The source will be Google's address. The destination will be 192.168.0.25. And what will happen is Linux, if it's in the contract table, if it's part of an existing connection, will change the destination address this time. So it'll be the opposite. And it's going to change that to 192.168.1.3, which is PC2 because he started this connection. It's going to compare that destination address after the NAT reversal takes place. On the way out, we do SNAT. That means source NAT. On the way in, we do DNAT, which means destination NAT. So after the destination NAT takes place, he's going to look at that new destination and send it down. It's going to compare the routing table. The LAN address is what that address falls into. So then he's going to send it, instead of out of the WAN, he'll send it out of the LAN. So in that way, we only let the LAN talk to the WAN, but not the WAN coming in, unless we do something called a port forward, but you don't have to worry about those. And but that's what we're trying to do. That's the big picture, okay? So in the next part, I'm going to set this up on the Linux machine. All right, so I will see you in part 2. Again, this is part 1 of 3 in our Linux Network Firewall series. I hope you enjoyed it this far, and thank you for viewing. And as always, it's Tyler with T-Tech.